Gamepad, keyboard, or both, today we are unlocking the power behind your character's movement. Welcome back, creators. In the last video, we set up our enhanced input system with the input action and the mapping input context. Now we're taking the next step, bring it all to life in C++. In this tutorial, I'll show you how to set up the controller, confirm that your input mapping context is active, and create a move function that responds to the gamepad or WASD keyboard input. By the end, your third-person character will be moving smoothly with responsive controls powered by the enhanced input system. If you've been following this series, you are laying the foundation of a complete third-person shooter in Unreal Engine 5. And if you are new here, don't worry, this video is beginner-friendly and connects directly with the progress we've been making step by step. I am Tony Munoz. Comment, like, subscribe, share this video, and hit the bell so you don't miss the rest of this free third-person shooter series, plus more tutorials and strategies to guide you on the path of becoming a successful game creator. And if you're ready for a real career transformation, learn more about the Game Creator Accelerator Lifetime Mentorship at Woolun.com. The path you've been searching for could start there. Enough of being stuck without getting job opportunities or a solid income as an independent creator. Now, let's get started. In the previous section, we defined the input action for move and the input mapping context to control that action with the keyboard and with the left joystick on our gamepad. Now we just have to implement the code. So go to Shooter Oasis and let's open our shooter character class. In the shooter character.cpp, let's add a couple of includes that we need to handle the input system. The first one is called the enhanced input component.h, include enhanced input subsystem.h, and include input action.h. I missed one character here, it's subsystems, and save. Now let's declare the input actions and the context in the header file. Because I'm going to use input action values, I will add an include named input action value.h. Keep in mind that you have to leave the header related to your class to the shooter character generated.h at the end of all the includes. If not, the compiler is going to generate an error. Now in the protected section, after the virtual void begin play, let's add a U property, edit anywhere, blueprint read only, and the category will be name input. Now I will do a forward declaration of U input mapping context. And let's name it player mapping context. As you can imagine, this is the mapping context that we created. The mapping context that is located on games input IMC player context. Let's add a comment. And now let's add the move action. Void move action const of input action value and value. And let's add a comment, function to move in all directions. You see that we have a green underline here. That suggests that this function has been implemented in the implementation file or in the CPP. To do this really fast, just move the mouse over the name of the function, click this tool, and select Create Definition of Move Action in Shooter Character.cpp. Now the function is created in the CPP. Look that we have the file, which is the CPP, and here's our action. Let's go back to our header. Now I'm going to copy this U property, forward declare U input action with a pointer to the action we created, which was the move action. And add the comment. Now let's go to the implementation. We are going to take control of a character because we are using a controller. In a previous video that you can check on the description, you have the explanation of what a controller is. And the place where we're going to set the controller is inside the begin play. So after the super begin play call, write if a player controller pointer to player controller is equal to let's cast a player controller. This line is first to create a generic pointer to whatever controls this pawn. It could be an AI, it could be a player. In this case, it will be a player. What it does is asking just one question. Is my controller actually a player controller, a human input? If yes, store that in player controller, which is this. If this character is not controlled by a human, like an AI, this block won't run. Each local player has a subsystem, which is special managers for different engine systems. So the next step is to check if we have this subsystem. We set it as a pointer to subsystem, and the value will be local player get subsystem enhanced input local player subsystem player controller get local player. The enhanced input local player subsystem is the piece of code in charge of handling input context for enhanced input. The player controller get local player gets the local player object tied to this controller. The UI local player get subsystem fetches the enhanced input subsystem for that player. If it exists, we store that into the subsystem. And now we are going to set the subsystem to be a default mapping context, which is the one that we created previously. Add mapping context, player mapping context 0. I just discovered an error we have here with the move action, and it's saying that the declaration is incompatible with the EU input action. And I think it's because they both have the same name. That's correct. So I will remove from this one the action part, save, and remove it here in the implementation. No errors. Now that we confirmed that we have a controller for our player and that we have a mapping context for it, let's go to the implementation of the move. Let's go down to the move. And first off, and which is a great practice, check that the controller is not a null pointer. Because we're going to use the controller, always check before using it and call the methods or the variables associated with something, check that this is not null, or else you can get some errors. The controller of our character is what gives us the camera orientation. Without it, we wouldn't know what forward means. First, I'm going to get a 2D vector that will define with X if it is forward or backward, and with Y if it is right or left. F vector 2D, let's name it movement vector, equals to value, the value that we pass, get F vector 2D, and that's it. Let's add a comment for this. Get add to the vector X, that will be forward, backward, and Y, which will be right or left. Now let's get the rotation of the controller. Const, let's define it as a const, rotator, and we'll name it rotation, equals to controller get control rotation. And also const f rotator yo rotation 0, rotation, yaw, and 0. The get control rotation gives us the full camera rotation, which includes pitch, yaw, and roll. But because we only care about the yaw, the horizontal rotation, because we don't want the character to walk up and down when the camera looks up, we set the other two coordinates to 0, which is a const value. We zero out the pitch and the roll. Now we're going to get two directions, the forward direction and the right direction. Those are the only ones we'll need, because if we want to go backwards, it will be the opposite of the forward, and if we want to go left, it will be the opposite of the right direction. Let's start with the forward. Again, constant f vector forward direction, and this will be f rotation matrix yaw rotation get unit axis e axis x, and I'm going to copy and paste here, but it will be right direction and the e-axis will be y. What we did is just to convert the yaw rotation into a matrix and then extract the axis corresponding to x or y for the movement forward or right. All this comes from the parameter value that we pass as an f input action value. Now that we have the forward and the right, let's add the movement. Add movement, input, forward, direction, movement, vector, y, and add movement. Well, I can do this, copy and paste for the x, and this will be the right direction. Good comment for this section will be something like get forward and right direction, adding movement, forward or right. The result will be that when you press W, the character walks forward relative to the camera, backwards if it is the S, and you will strafe left relative to the camera if you press A, and right if you press D. We have the controller and the function to moving, but there is just one thing that we have to add, which is the setup player input component. Here's where we're going to link the action we set up in Unreal with the function move that we just finished. After the super, let's cast the input component to enhanced input. If you enhanced input component, enhanced input component equals to cast check you enhanced input component player input component. By default, Unreal passes a generic U input component, but since we are using the enhanced input component, you need the specialized U enhanced input component. The cast check will ensure the cast is valid and crash it if it isn't. But in this case, that's fine because you expect an enhanced input. If not, you don't want to continue the game. Now let's bind the move action. Enhanced input component, bind action, move action, which is the name that we set on the header, to e-trigger event triggered this and the A shooter character move. This tells Unreal when the move action input is triggered, call the move action inside this function that belongs to this character, this function. The e-trigger event triggered means the action fires continuously as long as there is input, perfect for the movement axis like WASD or the joystick. Let's save and let's try our code. compile in Unreal, and let's play. If I play and I use the WASD, nothing works. It's not working. Why this is not working? Well, there is just one more thing we have to add. Open the base shooter character BP. We set parameters in a group called input. Look for input, and here you have the player mapping context and the move action. And as you can see, we haven't set this. We will select our player context that we created previously and the action that we have so far, which is the move action. Compile, save, play the game. And now, if I use WASD, you can see that the capsule is moving. Even more, if I use the gamepad, now I can move the character in different directions. And the good thing is that I can move relatively faster or not, depending on how much I use the joystick, the left joystick. You now have a working movement system for the third-person shooter character, fully powered by the enhanced input system in C++. This is one of the core building blocks for the shooter we are creating step by step. If this video helped you, don't forget to comment, like, subscribe, and share it. That way, you'll stay connected and won't miss the upcoming tutorials. Remember, if you're looking for a true career, a true transformation, visit Woolen.com to learn more about the Game Creator Accelerator Lifetime Mentorship Program. That could be the start of your path as a game creator. Enough of being stuck without getting job opportunities or a solid income as an independent creator. Until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.